Hi there, this is Walter Guillioli. I'm a student of Predict 413, and this is a very short presentation to cover what I did for the midterm project around predictive blood donations. In essence, this is a competition from the drivendata.org website where we have 576 observations with 6 variables in total, and we are trying to predict whether a previous donor of blood will donate in a particular month or not. So during this brief presentation, I'll cover briefly some exploratory data analysis that I did, some of the results of observations that I had, and then I'll get into the building and assessing some of the models to predict this variable. These variables. This is just a summary of the five of the variables that we have. Since we have 6, one of them is the target variable. I'm going to talk about that one next. Another one is just the ID of the observations. We're dropping that one from the EDA, and these are the 4 variables that we have. In essence, we have. I won't cover them in detail because I know you guys have seen them. The main points that I will make, and this will be reinforced in the charts below, is that we have outliers. We don't have normal distributions. So what I'm gonna do in 3 of those 4 variables is I'm gonna trim those outliers at percentile 99 to control a little bit my model and the outliers. The only variable that I won't touch is months since first donation. In this figure, you can see what I was talking about. You can see none of the charts in the diagonal, and the histograms are normal. Another thing that is very interesting to see is that number of donations and total volume donated have a perfect correlation of 1, and that is just too good to be true. So at this point, I could just drop one of those variables, but I'm just going to let the software do that. I'm assuming this is in part part of the project. The other thing that I did is I played a little bit with Box-Cox transformations to see if I could get more normality in the data. Unfortunately, the results that I got weren't as I would have expected. However, I ended up using both data sets with and without transformations to build my models and just compare them. And finally, I have a target variable, which is a binary one, zeros or ones, yes or no's, whether a person has donated or not. And so we have that distribution as well. Before letting the software pick the variables, which is something you can do for the model, I always like to explore the data and just get an idea of which of these variables are good potential predictors of the target variable. So usually what I do is I do these box plots here of my 4 predictors, and I slice them by donor, yes or no. And in essence, if I see big distributions in the data, that gives me a good indication that the variable will help predict, or will help my model. For example, if I go to the bottom right, months since first donation, I mean, the distributions are pretty similar. I see the line there and I see the median, and then I see the IQR is pretty close and the data is pretty distributed. So I'm not very excited about that variable. But if I look at months since last donation, for example, you see for the people that have donated, you see how that variable is very condensed in the lower end of the scale, and with a median of around 4, versus in the other ones for people that haven't donated. That didn't donate, sorry, for the particular month, it's over 11, and the data is more widely distributed. So that's very important. I just want to mention that I listed 5 examples here on how these techniques have used in the past. This one really called my attention, number 3, which talks about predicting what drives people to get divorced by year 10th. I'm gonna be married for 10 years next March, so I was happy to see this. That's not my case. I'm still happily married, so that was good to see here. In terms of the models, I did build 5 models. I picked simple models. I like logistic regression and I like classification trees. I could have done linear discriminant analysis, quadratic, or even random forest, but I like to keep it simple here. I think the main point is to play with the data and do the EDA and do some good models. And in fact, I got pretty good results in the competition. So I did a combination of logistic regression and classification trees, using the data transform or not and not transform. And finally, number 5, I did all the interactions with all the predictors, something I haven't really done before, but I saw our professor Doug Larry doing it, so I decided to do it, and actually that was the best model. Um, Once I got into measuring the models, I could have done many things. I could have done area under the curve, confusion matrix, misclassification, AIC, etc. I decided to keep it simple here, and I basically let the score on the competition guide my model. But I also did a misclassification rate, which is oddly, I got the same misclassification rate for all the models, and I'm still trying to understand that. I'm not sure. I took the training set and I split it in my own training set, 75% of observations, and then the rest as a mini test set. But I got the same rate, so I'm just not gonna take that. But I decided to include it as it was a good learning for me. My best model was number 5 that has all the interactions, and I got a pretty good score. I was just looking at the site right now as of July 24th at 7 p.m. here in Seattle, and I'm at 62 out of 3,048 people. So very pleased about that. Um, I think in general, I would have liked to have more data to test more models and have more observations, more variables, but this was a good introduction for classification problems. Thank you for listening, and I'm going to stop the recording now. I hope this was useful.